Hi there, in this video I'm going to make the valves and the valve guides for the Howell V-Twin. Now the valve guides are made out of mild steel, so I've just cut these pieces to size, and in terms of the valves they really should be made in one piece, but I tend to make valves in two pieces. I silver solder the ends on to the stems, so in this particular case they should be made out of stainless steel, but I've not got any stainless steel, but I've got some silver steel. So I've cut these pieces to length, these stems, and they're at 25 thou over the actual length that they should be. And what I'm going to do is machine the ends for the ends to fit on here, and I'll machine the ends to be 25 thou over the overall width as well. So that'll make these ends 0.111 of an inch thick. And once I've fixed them onto the stems using silver solder, I can then take off 25 thou to get them to the right length, and then I can actually cut the faces as well at the same time. So that's the plan. Now the valve heads are going to be made out of this piece of silver steel, which is 3/4 of an inch in diameter. I've already centre drilled and drilled through with an 1/8 of an inch drill bit. And what I need to do now is just part these off to be a width of 0.111 of an inch. Well, they turned out okay. The machined faces on that side will be fixed like that. So what I need to do now is to reduce these ends down to an 1/8 of an inch. Now it says here 0.510, but I'm adding 25 thou onto that, so it'll be 0.535 of an inch to take off there, down to an 1/8 of an inch in diameter. So I've set the carriage stop, and this is already 0.155 of an inch in diameter. It used to be 0.125, so that's 30 thou off, divided by 2 is 15 thou. So now I need to drill a hole in each of the stems. This is to hold a pin, a retaining pin, and I'm using this micro chuck. So I've got a little centre drill there at the moment. Once I've centre drilled, I'll go through with a 1/16 of an inch drill bit. Well, I've decided to change my approach. I found a 1.1mm 2-flute end mill So I'm going to go through with that first of all. My mill's not sounding good at this speed. I don't know what's going on there. So I don't know what's happening. Well, I don't know what's wrong with the mill. It sounds like a bag of nails in the gearbox when it's in high gear and running fast. Checked it out on low gear and seems alright, running fast. Put it into neutral and ran it, and that's okay, running fast. So I suspect it's a gearbox problem, but how you get into gearbox to that, I have no idea. But anyway, that's another job. So in terms of this, after going through with a 2-flute end mill, I went through with the 1/16 of an inch drill bit, and now I've cleaned all the faces up with acetone. So now it's a bit of silver soldering required. So I've put some flux on the stem and the head, and the main advantage of the way I turn these heads off, or the way I parted them off, is that it creates a slight burr on the end, so these heads can't go any further down on the stem. So that makes life a little bit easier. So there's a bit of silver solder on there, so now I'll try and heat from the bottom and get it to react. Well, it seems to have turned out okay. It did have a couple of goes at that one, but I think the silver solder's run through the joint fully. And what I'm going to do now is set up the compound slide on the lathe to be 45 degrees, because what I want to do is I want to cut these seats at the same time that I cut the seats on the guides. Hopefully it'll become a little bit clearer. So to check that I've got the 45 degree angle, I've worked out that if I move the cross slide that way by 0.1 of an inch, this distance here should increase by 0.1 of an inch divided by sine of 45, which is 0.7071. That comes out at 0.1414. So I'll move the cross slide 0.1, and that's pretty much come in at 0.1414. Okay, so first of all I need to get these heads down to the correct width. Now to cut the valve seats. and that should measure about 36 thou, and looks pretty close. So for the valve guides, my plan is to drill right through. I've already centre drilled, but drill right through with a 3.7mm drill bit, and then ream to 5/32 of an inch. So I'll do the reaming off camera. So the idea is to open up this end with a 5/16 ball nose end mill. But what I'm going to do first of all is, well, this is going to a depth of 0.45 of an inch. So I'm going to open it up initially with a 6mm drill bit, then a 7.5, and then I'll use that in the chuck. I don't think you're supposed to do it this way, but hey ho. Now I believe that it's not advisable to use end mills in chucks, but there is a reason for doing it this way, and you'll find out in a minute. So now I can cut the valve seat using the compound slide, which is in exactly the same position as it was when I actually cut the valve seats on the valves. And when I cut this seat, it's only 10 thou wide, but the fact that this part hasn't moved at all in the chuck means that it's going to be exactly perpendicular with the hole that goes through it. So fingers crossed, once I've cut it, when I put the valve in there, I'll have a reasonable seat. It's only 10 thou wide, so I need to measure it. It looks about that. Well, to be honest, it's difficult to gauge 10 thou in there. It's no smaller than 10 thou, so just put a valve in, see what it looks like. I think there's a bit of swarf in here. Ah, looks alright. So now I can start machining the outside of this guide. Now when I machine the blanks for the valve guides, I decided to machine them a couple of tenths of a thou over 0.406 of an inch, which will allow for a sort of a decent press fit into the cylinder head. Now for those following along with the Jerry Howell drawing will now realise I've goofed up, because I've just found that there's a little flange at the bottom which is about 15 thou wider each side and 25 thou in width. And I think the idea for the flange is you press the valves into the head from the bottom of the head upwards, and the flange will stop them from going any further. And I suppose from a design point of view that's belt and braces, because there's no way that these are going to pop out under pressure. However, the drawing also shows some Loctite grooves which I've just cut, and these grooves are around about 20 thou wide and 10 thou deep, so I made a little cutter to do these. And what I've done is I've made the top groove 40 thou from the top edge, so this is where this taper will finish, and the bottom groove is 60 thou from the bottom edge. So I've cut those grooves on all 4 valve guides, and I'm going to proceed on the basis of not having a flange, because to be honest, having a flange there really does sort of make the machining process a little bit more complicated. So what I need to do now is to cut the taper. Now the taper, the top end of the taper is 0.26 of an inch, and the bottom of the taper is 0.32 of an inch, and the length of the taper is 0.625 of an inch. So if you take 0.26 off 0.32, you get 60 thou. Divide it by 3, you get 30 thou. So to calculate the angle of the compound slide, I've got 30 thou, I've got 0.625, and I need to calculate x. So tan x degrees is equal to 30 thou divided by 0.625, which gets 48 thou. That equates to 2.74 degrees. So to calculate y, so this is the distance I'm going to move the compound slide when I'm making the cut. It's the sine of 2.74 degrees is equal to 30 thou over y. So y comes in at 0.6276 of an inch, which equates to 15.94 millimeters. So to check that I've got the compound slide set up correctly, I'm going to put a gauge on it. I'm going to move the compound slide 15.94 millimeters, and the difference should be 30 thou. So to check that I've got the angle right, I've put a gauge on here, set to 0. I've withdrawn the compound slide, set that dial to 0. So what I need to do now is to move the compound slide that way by 15.94 millimeters. So that's 15 full turns and not quite a full turn to get to just under 16. 1, 2, 3, 4, 5, 6, 7. That's 15 and 3 short of 16 is there. You can see there, hopefully, slightly over 30 thou. It's 31 thou, but I'm happy with that. So this diameter here at the moment is 0.406 of an inch or thereabouts. Needs to come down to 0.26 of an inch. So that's a difference of 0.146 of an inch. Divide by 2, it's 73 thou. So I'm going to have to move the cross slide 73 thou in total. I'll move it in 10 thou increments. And with each of those 10 thou increments I need to make a cut on the compound slide for a length of 15.94 millimeters. Just a fraction over 0.26 of an inch, which was what I'm aiming for, and it's 0.313. That's slightly under the target of 0.320, but I'm happy with that. Well, this seems to have worked out okay. I've done a bit of deburring because there were raised edges where I cut these little grooves in. So I think I've sorted that out, and there should be a decent press fit, I think, from what I can work out. And the fact that there's no sort of flange on the ends of these, what I'm going to do is I'm going to press them in from this side like that. I'm going to put some Loctite on these grooves. When I press them in, I'm just going to put this 20 thou sort of shim there to actually create that sort of flange gap. Not that it's important, I don't think. I'll also need to make sure that there's when I'm pressing them in, there's sort of like adequate sort of space on the press to allow that to come beyond the edge. So it's going to be a bit fiddly, so I'll do it off camera, then I'll get back to you. Well, maybe not as fiddly as I first thought. So this is Loctite 638. So I'll put that like that. Just press it home. Hopefully. Not very good, does it? Whoa. Got there in the end. So here I'm drilling one of the intake ports into the valve guide. Seem to work okay. I'll do the rest off camera. Well, they seem to turn out okay. Happy with those. Well, I was hoping to make the springs and lap the valves and do some compression testing as well at the same time, but unfortunately I've just realised that I don't have the proper gauge wire. So I've just ordered some of that, so that'll be subject to my next video. All seem to go okay, apart from the missing flanges, but I don't think that'll be an issue. I've never made any valve guides before that had flanges on them, so I think it'll be okay. I think I need to be thinking about something that will allow me to clean these parts up properly. I generally just use a bit of acetone, but I'm just thinking, you know, whether or not an ultrasonic cleaner might work. I'm not sure whether that's good on metal. I don't know. If anybody's any thoughts on that, I'd appreciate it. And I suppose the most worrying thing is the fact that my mill's making such a noise at high speed. I did some checks on it, and the noise only occurs at high speed on the high gear. On the low gear, not a problem. I'm just wondering whether or not it's a bearing breaking up. If anybody's got a Waco WM18 mill or something similar, who might be able to advise me on what it might be and how to resolve it, I'd really appreciate it. You can contact me by email, learningturningmetal@gmail.com. But anyway, in the meantime, I hope you enjoyed this video, and I hope to see you later.